Thank you, Ramses. Um, Hello, everyone. Thank you for attending. My name is Anne Allen. I'm the training coordinator for Compute Ontario. This session will go over what Compute Ontario Summer School is, how to enroll in courses, and how the courses are organized. I've pasted the link in the chat to the slides um, if you'd like to follow along. This year, the school is taking place from June 2nd to June 20th and offers a comprehensive curriculum of over 40 courses. Delivered by experts in the field, these sessions cover a wide range of topics, including advanced research computing, high performance computing, research data management, and research software, with presentations and workshops available at introductory to intermediate levels. Everyone is welcome. For more information about this year's offerings and other opportunities in the digital research infrastructure ecosystem, we recommend attending the summer school session overview of training opportunities in the school and beyond, instructed by Ramses Van Zon. This is the opening session for the summer school. There are two steps to getting enrolled in courses. The first would be to sign into the Compute Ontario training system. However, if you don't already have an account, you'll also need to create one. The second step is to enroll in courses. This requires you to select the course link of each of the courses that you're interested in and enroll. First, I'll review how to sign up and create an account. You'll want to follow the Create an Account link. I've included it in the title of this slide, but you can also find it on the landing page of the summer school under enrollment. The first step of creating an account requires you to enter an email address. Once you've submitted your email address, you'll receive an email and you'll need to click on the first link in this email to get to the third step, which is providing your account information and selecting Create an Account. Once you've created an account, you'll need to sign in. You can find the link to the sign in at the top of this slide or on the summer school landing page, also under enrollment. You may have previously logged in with your CCDB account. We're moving away from this, so if you decide to create a Compute Ontario training account, and would like to keep your account data, please email support@tech.alliancecan.ca with the subject COSS 2025. Just as a reminder as well, you can't use your email address as your username, and you will need to use the username that was emailed to you when you created an account. Your username includes COT- at the beginning, so don't forget to include this when signing in. Once you've logged in, you'll need to navigate back to the landing page. If you've signed in from the landing page, you can select the previous tab in your browser because the login page opens in a new tab. Once you're on the landing page, scroll down to the schedule and select Link to Course under a course that you're interested in. After selecting Link to Course, you'll see a page with the course description, and you can select the Enroll Me button to enroll in the course. Repeat these steps for all of the courses that you're interested in. If you no longer want to attend a course, you can also unenroll from a course. You can open the course's main page by logging into the training platform and navigating to the course homepage. You can do this by selecting the link to course again from the landing page or within your Moodle account under My Courses. Once you're on the course's main page, you'll see a More button on the toolbar. This is where you'll find the Unenroll Me from this course button. It will ask you to confirm before proceeding with unenrollment. Additionally, there are some tips for navigating the schedule on the landing page. All of the course times are listed in EDT, Eastern Time. There are so many courses at summer school that some overlap, so take a close look at the dates and times. If you unenroll from a course, you can always re-enroll later to access the materials afterwards. There's also a link to the frequently asked questions on the landing page under registration. I've also linked the frequently asked questions to this slide if you need it. I also highly recommend taking a closer look at the course descriptions, which can be expanded under each course. This will provide you with integral information such as abstract, the instructors, the level, We have three: introductory, intermediate, and advanced. You'll also find the format, which is often described with workshop, lecture, lecture and hands-on, webinar, or panel, but you may find your instructor has provided more detail. You'll also find the certificate information. We have two types of certificates: attendance certificates, which every course has, and you'll receive for attending the sessions for that course, and a completion certificate. These require that the instructor have a graded assessment, such as a quiz or activity. Lastly, you'll find the prerequisites, which describe the skills that you might need prior to taking the course. For example, you might need experience for a particular programming language. I'd also just like to note that these prerequisites do not include technological resources that might be used in the courses for certain activities. Courses may include the use of a laptop, may require you to access the provided Magic Castle account, or they could be course specific. Since courses provide instruction for any resources that are used during the course session, since most courses provide instruction for any resources that are used during the course sessions, these are not listed under prerequisites. I'd also like to note that you'll find all of the integral information about accessing the course sessions within the course Moodle page on the day of the event. Just a reminder, these are the links that we've covered so far. I've just gathered them in one slide for convenience. If you have any questions, feel free to contact myself or the support email with the subject COSS 2025. And now I think I'll move on to content overview. So in case you're unfamiliar with the summer school content, there are at least 2 courses running at all times. We try to schedule courses by subject matter so that similar subjects are not running at the same time, but there are exceptions due to scheduling constraints. The current unofficial subjects are topics such as high performance computing, research data management, AI and machine learning, bioinformatics, neuroanalytics, programming languages and tools, parallel programming, software tools and infrastructure, and security. We have a rough organization in the next few slides. I'll provide an overview of the topics or a brief sentence about the course when it makes sense. This information was taken from the course abstracts that were written by the course instructors. I recommend taking a look at the expanded description under each course for more information. The general HPC and overview courses includes overview of training opportunities in the school and beyond. This is essentially an opening course to the school to welcome users. There are also courses to help you with high performance computing practices, such as Introduction to Advanced Research Computing and Scaling Up HPC Workflows. We also have a course this year that explores the new H100 GPUs and how to use them. Research data management is scheduled so that none of the courses overlap. The first on the schedule is reproducible research practices and tools. It's a hands-on session that will provide researchers with tools and techniques to make their research process more transparent and reusable in remote computing environments. Research data management, a global perspective on making data fair, has 2 sections. The first half of the session will provide a high-level distillation and reflection upon a global policy brief, flagging areas where Canadian stakeholders can better support and promote fair data practices. The second half of the session will address the importance of the FAIR principles at a time when data are being suppressed or deleted. The Beginner's Guide to Data Curation provides an introduction to data curation concepts and best practices. Introduction to Alliance RDM services will highlight different tools and services that are available to researchers as they embark on their research journey. Enhancing the fairness of sensitive and restricted access research data, data deposit, de-identification, and reuse will focus on enhancing the fairness of sensitive and restricted access research data through strategies that support data deposit, de-identification, and responsible reuse. Implementing institutional RDM strategies is a workshop that will have participants discuss the recommendations in the report Building an Interinstitutional and Cross-Functional Research Data Management Community from Strategy to Implementation. Depositing in Borealis, the Canadian Dataverse repository workshop will support researchers with uploading data files of all types and examples of documentation and metadata for submission to an institutional collection hosted in Borealis. Using data collections in Odyssey and Scholar's GeoPortal in your research will demonstrate to researchers how to search, filter by variables, topics, and themes, as well as exploring and analyzing data using these repository platforms. Metadata in the DRI ecosystem and pragmatic introduction will aim to demystify DRI metadata by experiencing it in action across three data services: Borealis Scholars, GeoPortal, and Odyssey. Data management plans, research and RDM expert panel has researchers and RDM specialists share their experiences guided by a series of questions highlighting the evolving roles of researchers and data specialists in the planning process of the data management plan. I mentioned a lot of courses, so this is the second half of the courses that I mentioned. We also have artificial intelligence and machine learning. Machine learning covers the fundamentals and provides real world examples of how you might use machine learning for problem solving. Data preparation is a more detailed course that provides information on how to prepare your data for data analysis using machine learning. Introduction to artificial neural networks provides an introduction to neural network programming, which and sorry, which leads into methods to generate sequences. Text mining provides an overview of tasks such as de-identification, sentiment analysis, and document clustering, and the AI showcase explores the opportunities that AI provides in the HPC context. For bioinformatics, we have data visualization in bioinformatics, which explores key principles in visualization and effective strategies for plotting. Bioinformatics analysis of RNA sequencing data takes a look at the comprehensive RNA-seq pipeline from sampling processing methods to final differential expression analysis. Bioinformatics for pathway enrichment analysis takes a closer look at key concepts and methods for pathway enrichment analysis, and bioinformatics long-read sequencing applications explores long-read sequencing with a focus on PacBio hi-fi sequences. Just check in the chat real quick. Okay. In neuroanalytics, computational and mathematical analysis for a simple network model of associative memory delves into the fundamental concepts of an associative network in neural computation. Network analysis of neurophysiological data provides an overview of the analytical process for working with neurophysiological data and deriving insights from it. We also have a variety of courses on a number of programming languages and tools. This includes the programming languages R, C, Fortran, Python, Rust, Julia, and C++. You'll find on these 2 pages. We also have many courses that explore parallel programming. Dask explores how Dask can help with the parallel programming limitations of Python. Data parallelism and model parallelism for scaling training across multiple GPUs provides an overview of activation, checkpointing, gradient accumulation, and various forms of data and model parallelism. Multi-core parallel programming starts with an introduction to OpenMP that leads into intermediate content and incorporates hands-on components. GPU programming CUDA should provide students with the knowledge necessary to begin developing their own GPU applications. And lastly, we have a course on parallel programming with MPI. Next, we have software tools and infrastructure, which includes working with Jupyter on the clusters. This course dives into the features of Jupyter that can be used on the Alliance clusters. Introduction to version control using Git teaches the basics of version control. Introduction to Linux Shell provides users with information on how to use Bash. Scientific visualization explores how to use Matplotlib and Paraview for visualizations, and using containers, Aptainer introduces how to use Aptainer and tools such as Conda and SPAC within Aptainer on high-performance compute clusters. We also have a course on data security, which is important to highlight as it reviews tools you can use to prevent the theft of your data. That was a lot of information. Just a reminder, so I'm just going back to the important links just as a reminder. And if you have any questions, feel free to contact myself or the support at tech.alliancecan.ca.